Hello everybody, let's see a transistor amplifier from the last video in a circuit simulator. So I'm going to add a transistor. Here, the transistor, I'm going to be able to add it here. There we go. Then we've had a 2K resistor, a 2000 ohm resistor to the left of the base. So I'm just going to add I'm going to add a 2K resistor here on the left of the base. Very well. Then below it we've had an AC voltage source. So I'm going to add it. So we have add AC voltage source to terminal like this. And following that, we've had just the 2-volt battery, the 2-volt DC voltage source. It actually was on this side, and then we can press shift and drag it. You can also press alt to drag the whole thing. There we go. This is 2 volts. And this was 0.5 volt. Okay. I'll press shift to make it a little bit longer. Then we just had a wire going from the emitter, from the emitter down to the DC voltage source to complete the circuit. So here we have a circuit. On this branch, it's going to be the current IB. On this branch, it's also going to be current IB, and on this one as well. In fact, this whole thing is one branch actually. All the way from the base, all the way to here, it's one branch, and it's going to be the current IB. On the other hand, the current in this branch, the branch that I'm highlighting right now, the current, this branch that's below the emitter, it's going to be the current IB and IC together. And IB plus IC is the current IE. So it's going to be the sum of the current IB and IC, but the current IB specifically is going to flow here and then turn to the left. Then here it's IB only, here it's IB only, here it's IB only, and here it's IB only. Okay. Maybe it will be more clear when I draw the rest of the circuit. When the rest of the circuit is drawn, it will be more clear. Here we've had actually a resistor, we've had this line, we don't need it so long. Just here we had a resistor, just a 50 ohm resistor. Following that, so this is the collector, and above that we have the 50 ohm resistor. Following that, we have a wire here. Here we had a 10 volt voltage source. So I'm going to add a voltage source. Just going to add it like this. Then I can shift and drag it to put it here. This is a great circuit simulator in my view. So I'm going to 10 volt voltage source. I change it to 10 volts. There we go. Then I'm going to add one more wire here, and I'm going to close the circuit here. So here on this branch, right here as well, across the DC voltage source, and down across the resistor, it's going to be the IC current, as we saw in the last video. And here on this branch is going to be both the IB and IC, but IB is going to go to the left, and IC is going to go to the right. But on this branch, it's going to be IB and IC together. So let's start, and let's see if it's working. And let's see in particular if the voltage across VCE matches our predictions. It looks that way. I'm going to right click and click max scale. Speed it up just a little bit. It's going to increase the scale in a moment, right? It did increase the scale now. So we see it at the maximum. So we predicted that the maximum will be 8 volts and the minimum will be 5.5. That's what we calculated in the last video. And indeed, you see the maximum is 7.98 and the minimum is indeed roughly 5.53. So it's indeed roughly 5.5. So the voltage that appears across VCE is the same shape as the voltage across the small AC voltage source, but here the voltage only goes from half to minus half. So the range is 1, whereas here the voltage goes from 5.5 to 8. So the range is 2.5. So you can say that it amplified it 2.5 times. Maybe the gain, I'm not sure if it's proper to use the term gain here, but if it is, then the gain is 2.5 times. Because here the difference is between half and minus half. Here the difference between 5.5 to 8, 2.5 volts. And the shape also maintains the sinusoidal shape of the AC source. The AC source has a sinusoidal shape, and the voltage across VCE also has the same sinusoidal shape as that small AC source. So we saw that, and we explained that in the last video. Now the only thing is that the shape across VCE is inverted. This is an inverting amplifier, so the voltage shape across VCE is the flip side, or kind of like the mirror image or something like that, of the voltage, of the small voltage of this AC voltage source. Right click, so we can right click on the original signal, click view in scope, and here it also shows the current in yellow. So I'm just going to right click properties and remove the current. There we go. I'm going to run it. And now I think we would be able to clearly see that the voltage here, VCE, is the flip or the inversion of the voltage in this small voltage source. So I'm going to stop so we can see. Now notice that here, now the voltage source is at a maximum, the small one. And here the corresponding value for VCE is the minimum. On the other hand, when now the small voltage source is just about at the minimum, and the big one, the VCE, the voltage across VCE is almost at the maximum. We can do it here, we can do it again. Maximum, minimum, do it again. See minimum, and here it's maximum. Here it's at the max, here it's at the min. So we can just see that the voltage across VCE is indeed amplifying the small voltage across this voltage source, but also not merely it's amplifying, but it's also inverting it. It's like a mirror image of it. But even though it's a mirror image, it retains the original shape, just the flip of the original shape. Okay, let's let it run a little bit longer so we can see the pattern. Right, so it works. The transistor VCE amplifies the original AC source, but it also flips it. That's why we call it an inverting amplifier. Right? So hopefully this works. Yep, we can see that it works. Great, so hopefully this video was helpful. Great, so I'll stop right here. Thank you for watching the video.